first two problems and just multiply by the LCD and be done. You have to have like terms in your denominator. So make sure when you're doing this, those bottoms, without a calculator, combine the fractions and reduce your answer to lowest terms. Just do the first two, okay? Just do the first two. So we're looking at 2/8. We're doing the bottom two. And, you know, calculator free. But remember, you can't multiply it just by the LCD because it's not set equal to anything. It is a relationship that you have to know and set up fractions for. Okay? And this is PreCalc section 2/8, day 1. We'll probably get to example 6 today. So know that when we get through this. And this is about sign charts, algebraic techniques and graphical techniques. So in that first one, I know, hopefully you see it. You got to multiply that first term by x over x. You got to get like denominators. Okay, so we got that like denominator thing. And I'm just multiplying by 1. Are you okay with that? X over x is just 1. So I've taken that first term, I'm multiplying 1 by it. It's a special form of 1 to change the denominator. So it becomes x squared over x plus 5 over x. Or excuse me, x cubed over x plus 5 over x, because x times x squared is x cubed. And now my fraction becomes x cubed plus 5 all over x. Now again, I cannot just clear the fraction by multiplying by an LCD because I don't have it set equal to anything. If you're doing that, we're doing it wrong. Okay? It's an incorrect statement. And the second one, when we're looking at that, I'm multiplying by x over x again. Seems like a theme, right? Except now I've got x cubed over x minus 3 over x, and that's okay. Now, I'm going to do the other two tomorrow as our openers, just to kind of get you thinking about other things and that. So we're going to look at those other two tomorrow. We're going to do some more practice today with them. But keep in mind, I've had people just multiplying things by the LCD, and you can do that if it's set equal to something. But if it's not, you just can't just willy-nilly just clear the fractions out. Okay? Now, going on to our next page, if it actually moves. Okay, we're looking at solving inequalities in one variable. I'm going to show you using sign charts, algebraic techniques, and graphing techniques how to do these. Okay, so a polynomial inequality takes the form of f of x is greater than 0. Remember, that's positive. That's a positive answer. F of x is greater than or equal to 0. That's 0 or a positive answer. Okay. It's 0 or a positive answer. F of x is less than 0, that's a negative answer. F of x is less than or equal to 0, which is 0 or a negative answer, and a negative answer. And f of x not 0. Okay, so when would that be? And where f of x is a polynomial. There is a fundamental connection between inequalities and the positive or negative sign of the corresponding expression. To solve f of x is greater than 0 is to find the values of x that make f of x positive. So everything above the x-axis, okay, when I'm looking at the graph. Okay, to solve f of x less than 0, everything below the x-axis. Okay, and it's specific. When I don't have where equals to, I'm not interested in where it crosses the x-axis, my zeros. I'm just considering above and below. Okay. If the expression of f of x is a product, we can determine its sign by finding the sign of each of its factors. In order to do this, we'll make something called a sign chart. So really what I'm relying you to know is that a negative times a negative is what? A negative time, oh wait, I said a negative times a negative, and I apologize, you answered that question, but a negative times a positive would be a negative. Okay, a positive times a positive, we know is positive, and just like I said earlier, that's positive. So we're actually running through those types of things in our heads. I'm not worried about a specific value, I'm worried about a general sign value. Okay, and the behavior in an area between zeros of our function. Okay, so the first thing we're going to do when we do this, we're going to make a sign chart, we got to find critical points, or our zeros, or our vertical asymptotes, or where it doesn't exist at all because we're dividing by a square root of something, or we're dividing by whatever. But we have to look at our critical points. Find the critical points where f of x is 0 and where f of x is undefined. Okay. Then make a number line and place these critical values on it. Okay, that's step 2. Step 3, you're going to pick x values between these points to determine what's going on with the behavior of our function. Is it going to be above the axis or below the axis? A little FYI, above the axis is positive, below the axis it'll be negative. Okay, and based on that, we'll be able to find our answers. Now, I'm fully aware that you'll be able to do this using a calculator and looking at the graph, finding the intersections of your graph and your x-axis. When I'm asking you to actually make a sign chart in the test, I expect to see the sign chart. It's an 8-point question, no sign chart, you miss 5 points right off the bat. Okay, so you have to make sure you know how to do these. People, well, I can do it on the calculator. Great, 3 points out of 8. Tell me what the percent is. It's less than 50 on that question. Okay, and it's not a difficult question. It's just that you have to make sure you show your work. Okay, now, in example 0, I kind of hedge back and forth about doing it, but I want to make sure the basics are covered. Okay, so I'm looking here at x plus 3 and x minus 4 squared. That means I've got a multiplicity. You know, at 4, it's going to bounce or be tangent to my axis, and it's going to cross at negative 3. And I got my zeros. Those are the things I was talking about right there. So I've got negative 3 and x is equal to 4. Now, I know that this at 4, I've got a multiplicity of 2, right, when I'm thinking about it. So right now, I've got negative 3 is a 0 and 4 is a 0. So I'm talking about step 1 was kind of determined. I don't have any vertical asymptotes right now. I'm not going to have anything going across that's undefined about my sign chart. But right now, it kind of looks number line-ish, right? And it's number line-ish because I got 4 on the right, I got negative 3 on the left, negatives on the left, right, positives on the right. I put zeros in there because negative 3 is a 0 and 4 is a 0. Now it's my job to look at this, and I'm considering the fact that I've got factors, and I think I wrote that function right there. I've got this function right here that I'm going to consider the factors of and what their signs are to the left of negative 3. So if I pick a number to the left of negative 3, I don't care what it is. This can't be negative 3. So negative 10. I put negative 10 in as x for x plus 3. Well, that's going to be a negative value, right? So that's negative. I put negative 10 in for x. Negative 10 minus 4. That's going to be a negative. So what's a negative times a negative? Positive. So I know my function's above the axis when I'm looking at the graph there, without even looking at the graph. This is a skill I need to make sure you have and you know that it'll be a positive in this section. Now, between negative 3 and 4, I have the value of 0. Plop in 0. I've got 0 plus 3. That's a positive answer. 0 minus 4. Negative, but remember, and I lied here. I forgot something here. I was getting carried away. That should be squared. Okay, I got a negative and a negative. So that should be a negative answer. So that was my bad. Okay, and here I should be squaring that, so it's a negative times a negative, it's positive, so this is my positive when I pop in 0. And I put up on anything on the right side of 4. So 10. I got positive, I got a positive, and I got that squared. I got a positive, and I got a positive squared. So this can be positive as well. Okay, now I'm all happy with that. Are you okay where I get negative, where I get positive, and where I get positive? And does it make sense that it's positive on either side of 4 because my multiplicity forced a bounce? It should be positive, positive, or negative, negative at that point. So how do I use this? Without even looking at my graphing calculator, I can look at this function, or this sign chart, and be able to tell you when it's positive. Now, there's no or equals here, so it will be positive between negative 3 and 4 and infinity. Okay, I got to ask though, why aren't I saying between negative 3 and infinity as it being positive? What happens right at 4? It's 0, right? Okay, so it's 0 right at 4, and they're asking for when's it greater than 0. So that's why I have that as my interval, as opposed to -3 to infinity as my interval. Okay, and I'm not including if 4 as an endpoint as exact, because at that point I got 0. Now, if I want it negative, I look at the bottom part, because it's negative here on my left side. And from negative infinity to -3, I've got a negative value in my sign chart. Now, checking the graph, it should make sense that that's the case. So this is my -3. Here's my 4. Okay, so from negative infinity to -3, it's a negative value. And from -3 to 4, it's a positive value. It's above the x-axis. And from 4 to infinity, it's still positive. It's still above the x-axis. Okay, so that's the method of the madness is what's going on. But the big thing is about setting up your sign chart. Because the expectation isn't about you being able to tell from a graph when it's positive and negative, but it's you telling it from not using a calculator at all. Okay? Of what's going on. Now, in this next one, this is really similar to what we just did. I want to talk about the fact that I've got x squared plus 1 in this, okay, an irreducible binomial in this case. That's quadratic, okay, x squared plus 1. If I tried to factor it any further down, I'd have imaginaries. But what do I know about the value of this at any choice of x, that x squared plus 1? What will it always be? It'll always be positive. So although it's an extra piece of information, in this case it's always positive, you should be able to start out with your graph the same way. Please give it a try. You just did something very similar to it, so I want to see where we're at. We have found our critical values, our zeros. We don't have anything dividing here, okay, so we won't have any asymptotes. I know that the graph looks like this, okay, but I want to be able to set up the sign chart, and remember, sign chart's all about factors and whether the factors are positive or negative. So go ahead and find answers for those. And remember, what I'm asking you here is, when's it 0? When's it positive? When's it negative? Okay, it's another way of me asking those same questions. So when's it 0? When's it positive? When's it negative? It's a very similar sign chart to the previous one. Okay, as we go through, because of that irreducible quadratic. Okay. So I'm looking at my factors here on this side and that side. I have one more. I have a minus, plus, and a minus squared. I have a plus, a minus squared, and a plus, a plus. And that plus is squared when I set up my sign chart. Now, it's the setup that's the issue. Are there any questions? Good, bad, ugly. Okay, now remember, this part here, I've got 0. I'm wondering about my factors, and my factors are x plus 3, x squared plus 1, x minus 4. X squared plus 1 is always going to be positive. But down here at -7, if I pick -7, I put -7 in up here, I get -4. Put -7 in here, it's positive. Put -7 in here, it's negative, but I square it. So that's why it's just negative right there. So that's what I'm talking about, it's negative. I do the same evaluation between -3 and 4. I can pick 0, so I'm going to grab 0. I put 0 and I got a positive, and I got a negative squared, so it's going to be positive coming out of that section. Okay. To the right of 4, I don't care what number you pick. Pick something easy that you can evaluate quickly. 10 is always the one I like. Okay, 10 plus 3 is 13, that's positive. 10 squared plus 1 is positive, and 10 minus 4 is positive still, but it's squared, and that's why that's positive as well. And it makes sense according to what's going on here. I got my 0 at 4, so I got my 0 at 4, I got my 3, my negative 3 there, and I'd be able to find between negative 3 and 4, my function's positive. Up to negative 3, from negative infinity to negative 3, it's negative. And here, from 4 to infinity, it's positive. But able to read my sign chart, I should be able to look at my answers here as I go, and I'll get rid of that. So are there any questions about this? This being our second sign chart. It's all about us determining when the factors of a function are positive or negative in between critical values. Okay, and how do you show your work? This is how we're showing our work. This is what I would expect to see if I say, hey, use a sign chart in order to answer the following question. Okay, it's a method that I'm actually testing on, and that's what I would like to see. Okay, so you'll have points awarded if it's there. I'm fully aware you can find it another way, but you won't get full points then for it either. Okay, so know that. If you're asked in a question to do a specific method, you need to fulfill the requirements of the question by fulfilling the method you're asked to show. Solving polynomial inequality analytically, okay, I've got that thing over there. But give me a list of possible zeros. And remember, possible zeros, 24 over 2 are my possibles, right? That's what I got to set my list of all possible zeros. That's my first thing I'm asking you to do, is list all the possible zeros in that section. Okay? Since I got 24 over 2, remember A naught over AN, okay? And it's plus or minus factors. Go, come up with a list of possible zeros. This is a review of what we've already done, and we've done a couple assignments with them. Remember, when you make the list, you got a possible plus or minus when we do these. Plus or minus when we take these on. Now, as I'm going through this, I got 24 and 2. And remember, the factors of 24. 1 and 24, 2 and 12, 3 and 6, 3 and 8, 4 and 6. Okay, and 2, 1 and 2. But I also got to keep in mind I have the plus or minus versions. So when I'm considering this, I got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. That's just dividing the top ones by 1. Dividing them by 2 gives me everything this one does, except I'm missing 2. I'm missing when I get 3 divided by 2, so plus or minus, and 1 and divided by 2. So I got 1/2 and plus or minus 3/2. Okay, now when I do this, I've got to consider the fact that I can look at the graph, no problem, and I see 3 pretty reasonable ones. It looks like I got 3 halves, positive 3 halves. I got 4, 1, 2, 3, 4, and I got negative 2. But I'm looking for the actual list because that was what I was asked to provide. Okay, that's thing 1 in the problem. Thing 2, use synthetic division. Now, the drag about this is I did this in back because after I finished, I was going to factor at the end, and then I considered my question itself, and I go, you know, I'm asked to use synthetic division to show that these are factors. So let's use synthetic division. I decided 4 because it's out there. It's right there. Okay, it's also on my list. Okay, and I'm also going to use 3 halves, but I'm going to save that one. I'm going to use negative 2. So that's why I'm doing my list the way I'm doing it, because they asked me to do it this way. This is me fulfilling the requirements of a question on a test. They're looking for synthetic division, so I'm going to give it to him. I've got 8, negative positive 1. I got 4, I got negative 6. I got negative 24, I got a 0. Well, my other one's negative 2, so let's go after that. So I've got 2, and I got negative 4, which is giving me negative 3, so I got positive 6. Now I got another 0. But I got 3 halves at my end because that was one of the ones I was supposed to find. I'm fully aware at this point I got 2x minus 3, and I could use zero product rule. But the question asks, use synthetic division to find the factors that will work. So I'm showing synthetically that 3 halves times 2 is 1, or 3, excuse me, and then I got my 0. Okay, I've used synthetic division the way they asked me to, and they're asking list all possibles. Got it, got all my factors, got my zeros. I could even write them down. I got my zeros, my factors right here, my zeros, my factors, and that should be actually right there. I don't know why they bounced, but I'm missing something. Okay, as I'm going through, and I can actually, they don't ask me to set up a sign chart. Okay, they don't. They ask me to come up with an answer. What are they asking my answer to be? I mean, I did all sorts of stuff of showing factors, picking out factors and stuff, but really, what am I supposed to solve for my answer? What's my answer supposed to be? When x is positive. Because it's an equality. I'm supposed to find when x is positive. So I see that, and I could do my sign chart, and I'll be able to pop this stuff out. It's positive, it's negative. This can be positive there. And I can actually see that from the graph that I have in my calculator. I could show to make sure that, double check that I did not have fat fingeritis when I popped it in. So I've got all that information. Okay, now I'll wait for you guys to get that done because I just don't want it to be a mystery how I do that. And remember, I'm taking these factors, I'm putting in value less than negative 2, like negative 10. This is negative. Wow. Sure, this is negative. That's going to be negative. They're all 3 negative, that's why it's negative. Something between negative 2 and 3 halves, 0. I love putting in 0. It's great. I got a negative, a positive, and a negative. A negative, a positive, and a negative. Well, that's positive. Okay. Something after 3 halves. 4. Can't be 4. Got to be, well, I don't know, 2. Put in 2. Negative, positive, positive. Negative, positive, positive. Got it done. It's negative. Anything after 4, 10's great. Positive, positive, positive. I'm all good. Okay, so it's going to be positive. Let's revert that so I don't have that issue. But now, keep in mind, I'm asked to find where is it positive. And they didn't say that in the question. They said solve this relationship. For what values of x will this be positive? Not 0, but positive. It's positive here between negative 2 and 3, and it's positive between 4 and infinity. And we can even see negative 2 and 3, or 3 halves I should say, and 4 and infinity. So when I'm looking at this, I got my answer, okay, for when this is going to be positive. I should just take this and 2x minus 3 is greater than 0. I can actually get it greater than 0 when it's not equal to, excuse me, negative 2 to 3 halves and 4 to infinity. So that's my answer. This is my supportive work. They didn't ask me to do a sign chart, but I did it anyways because that's what we're doing today. I wanted to make sure how I did a sign chart and got it done. But are you okay with how to answer that? It's not bracketed because I'm not asked about when it's 0 or positive. Okay? It can't be exactly because of 0. If I had that little underline in there, I would have a square bracket to finish out my solution. But pay attention to what you're asked to find Make sure you're finding the things that are asked in the problem instead of just an answer you feel is right and then moving on. Okay? You guys paying attention to that makes grading them easier and actually collects all possible points for you as well. Okay? Solving polynomial inequality graphically. Now this one's nice. I want to do this graphically. Okay? So pull out your graphing calculator and pop this graph in. See if I can get my graphing calculator up. Now it's important for me to make sure that you know how to use your technology, but this is a problem where I specifically ask you to use your technology. Okay, so scoring on the problem will be, we'll follow along. It won't be as many points because you don't need to show algebraically how everything works. But if I ask you to show a sign chart, my concern is that you're showing the sign chart as we go. We've got x cubed minus 6x squared. Keep in mind, as I'm entering this in, all this gets solved to the left while I'm doing this, so that's what I'm entering into my calculator. Or an appropriate function for that, properly ordered. I'm sure I've got this in here this way. So hopefully you're seeing this in your calculator. I got a positive 8x minus 2. You could have put negative 2 plus 8x. Your calculator will take it that way. It won't go, oh, that's the wrong direction. Okay, so it's pretty friendly that way. I'm going to make sure that it's going to take a squared window. Okay, I'm going to put in 5. Ooh, didn't take that very well, did it? Let me see what's going on with that over here. Sorry about that. Zoom. Let's go with a 6 standard. Okay, there it goes. Not sure why it didn't take the first one. But there it is. There's my function. Okay. Now, I can, on my function, now I know this, I can find my zeros. I can find this 0. I just hit and second calculate. Okay. Finding my 0. Hit enter. And I'll hit enter again on that. And I'll go over on the other side of that 0, on the right side, and do it again. And that's my first 0, 0.3248, okay, or 0.325. Remember, in this class, in this course, we have to have 3-digit answers past the decimal. Okay, so it's 0.325 is one of my zeros. Okay, so I can find the other zeros in a very similar fashion this way. All right, and we should be able to see them, and those are the zeros that we found as we go. Now, that is an example of what we're doing with our calculator in example 3. Now we got that information, we got to start thinking about it critically. I am looking for when the function is 0 or negative. Do you see why I'm saying it's negative or 0? Okay, it's the direction of my inequality sign. 0's bigger, so the function, for what values of x? Will it be negative and or 0? So when I'm doing this, my answer is going to have my brackets from at 0.325, and a bracket at 1.461, and a bracket at 4214. Because it's 0, and I guess I had open, those should be closed in. I just tried to show that, hey, I'm including that value, and it's got to be closed in there. when we're taking care of that. Okay, so that's my solution of this. I expect on a question that you're telling me what the zeros are, that you're telling me where you're checking those. Okay, from there, I'm looking for the function you're putting in, you're telling me what the zeros, and you're telling me what the solution is. Yes, sir? You use the negative sign for 2 versus the negative. Okay. Yep. And that should graph out real nice after that. Is it going okay? Your graph and my graph should look alike. Okay. It's really funky. It'll accept it. It doesn't tell you it's an error either. It's just the graph doesn't look right. Yeah, it's just a weird thing. I think what it does is it looks at it as you're multiplying it by a negative. So then it goes on and does that. Okay, so now, graphing calculator, all covered. Now let's look at really what's going to happen with a function like this. I'm asking for the solution when it's positive. I'm asking for it's positive and 0. Okay, so remember that's a little different sometimes. And I'm asking when the solution is negative, when it's negative and 0. Okay, but now let's look at the graph itself. I gave it to you. Does this solution graph cross the x-axis ever? So won't it always be positive? Because it's above the axis? The answer to this is always positive. And I got some people that will look at this and go, I don't know what you're talking about. For every value of x we can put in, it'll always be a positive answer. We can see that graphically because it's not below the x-axis. So if I'm looking for a solution where it's positive in this first one, it's from negative infinity to infinity. And when I'm looking for a solution where it's positive and 0, well, you know, negative infinity to infinity. Now, if I was asked, when is it 0? Does it cross the x-axis? So because it doesn't ever cross the x-axis, it can't be 0. Okay, it can be positive and 0. I've got it covered. You know, it's positive from negative infinity to infinity. But it can't be exactly 0. There's a null set, no solution to that request because it isn't 0 ever. Matter of fact, it's never negative. So I've got a null set or empty set. Okay. I think when I was prepping this, I did null set. It really doesn't matter. They're synonymous. Okay. There is no solution set to this answer because there is no solution. It doesn't cross the x-axis, so it can't be negative. And because it doesn't cross the x-axis, it can't be negative or 0. So it's the same answer. Okay. In a like manner, we have the answer to like example 4b to deal with. But keep in mind the visual of the graph itself. I'm not having you do a sign chart on these because they don't require it. The inequalities associated with strictly positive polynomial function, okay, have unusual solution sets. Now I give you the picture, and we want to talk about the solutions themselves. So in this like manner, we're looking at example 4a. Okay, your turn. Decide what the answer should be. Your turn. The graph is provided. Think about what that represents in that visual. You may have to enter the graph into your calculator to find the zeros. Okay, so keep that in mind as you're going on working on something like this. You need the definite 0, and I gave you something that kind of seems like a little funky. But maybe if you look at the zeros itself, you can figure that out. Now, as we look through this problem, you've got to keep in mind that this part of your graph is affecting this over here. Okay? This part of your graph, that's your multiplicity of 2. That's where your x is 2.5. Okay? Because you got a 0, a 2.5 there. That makes your bounce happen. So as far as everything being above 0, right here at 2.5, you got a 0 at negative 2.5. You got a 0 to deal with. So it's positive from negative infinity to negative 2.5. And it's positive from negative 2.5 to infinity as we go through there. I wanted this one. Okay? So that's why it's that, but it's always positive or 0 along its entire from negative infinity to infinity because of the or equal sign. Notice the difference in the answer. Are you okay with those two? Okay. I'm tap challenged today, so I've got to get this going. But now I look at the inequality. When's it less than 0? It can't be 0. When's it negative? Well, this is never negative, so it's just like that last one we just did. Okay. Null set, empty set, I don't care how you answer, it's your choice. Or there's no solution, there isn't anything below the axis. Okay? And when is the solution negative or 0? Well, the only time, I've got negative 2.5 is where it happens, or negative 5 halves. Okay? That's my solution, and there's a couple ways you can do it. You can make the setup as, negative 0.5, but it's 0 right at negative 5 halves. Are there questions about what I'm having you do? Is it making sense? Looking at the graphs as you're going. Okay? So make sure you start recognizing what the graph is giving you and what the sign chart is giving you, and know how to read both, more importantly set up. I'm a little concerned about this next one. If you put this in your calculator the way it writes, it'll be 2x plus 1 times the quantity x minus 1. Okay? Because your graphing calculator will divide the first one and then multiply the next term to the top. It really should take on this form. The red form I've got here is really the intent of this graph. At least when I wrote it up, or it was written up. I'm a little concerned when there's that slash and then they don't have it in brackets. Ideally, there should have been brackets on the left and right of the denominator term. So now what I've got to determine in here is I'm looking for all critical values, not just my zeros, but my vertical asymptotes as well. Okay, so this value, this graph will be 0 when 2x plus 1 is 0. And for what value of 2x plus 1, so that's why I'm solving that. That's why x is equal to negative 1/2. Okay, the bottom doesn't determine 0. It determines my vertical asymptotes. So it is undefined at negative 3 and positive 1. Okay. So what's that look like in my sign chart? When I'm doing my sign chart, I've still got my critical values. I got negative 3, I got negative 1/2, and I got 1. At negative 1/2, I got a 0, but at negative 3, negative 1, or positive 1, I've got that undefined area. Okay, my vertical asymptotes. I'll bring those up so you guys can see that sign chart. Okay, so I'm looking at those vertical asymptotes. Okay, now, how do I deal with a sign chart with this type of situation? I still pick ranges, numbers inside ranges. So I'm going to pick a number way down here on the left side of negative 3. Oh, negative 10 looks great. So I now look at negative 10 into 2x plus 1. Okay, well, it's a negative value. That's my top value. Negative 10, the bottom value is negative, negative 10. So I've got 3 negatives. Are you okay that negative 10 would force these to evaluate negative in all 3 of those spots? Okay, it's my example problem. And I'm just concerned about the signs. I could care less about the result. It's the signs. Because I know that with this result, I'll have a negative on the bottom. It'll be negative from negative infinity to negative 3, not including negative 3. Okay. Now, as I'm looking at this, I also have, working with my sign chart, from my undefined to my 0, I have to do that. So I'm going to pick 0, the actual value of 0 for x. I put it in, and I got a plus, and I got a minus on the bottom. So it's a, oh, sorry, that was my 0. I apologize for that. Should have been a negative. I was a little shocked when it came up there. Okay, should have been a negative on that. But I'm just doing a negative because this is my 0. Negative 1/2, negative 3. Here, say I put in negative 2. Negative 4 plus 1, negative. Positive, negative. That's what I've got for my sign chart. Now I got my 0 on this side of negative 1/2. On my right, between negative 1/2 and 1. And I don't have my sign chart drawn to scale. I just set this up so that I can get my signs in there. I get to pick 0 this time. I put 0 as 1, positive, and a negative. And that's what I've got there. So my determination of those sections is that and that for my sign chart. Now, the stuff to the right of 1, like 10, 12, 15, pick one of those values and pop it in. The top is positive, the bottom left is positive, bottom right is positive. So it's all positive as I'm going through there. So I've evaluated my sign chart, and now I'm asked, when is my function greater than 0? When's it positive? Well, it's positive between negative 3 and negative 1/2, and from 1 to infinity. Okay? And when's it negative? It's negative from negative infinity to negative 3, and it's negative from negative 1/2 to 1. So I should be able to pull that interval out of my sign chart and be able to look at my graph and be able to determine that as well. Notice that on my graph itself, it does not have my vertical asymptotes. So I need to actually find those and realize that that's what's going on here. And have you noticed that I'm not concerned with my horizontal asymptote? I'm more concerned with the vertical asymptotes, about the changes of my sign of my function. Are there any questions regarding those? In 6, when we're looking at a situation like this, I need it as a rational function. So I need to get like denominators, multiply the left side by x minus 1 over x minus 1. Okay, multiply this by this part of the function by x plus 3 over x plus 3. Okay, in order to set up my next part. So I've got x minus 1 over x minus 1. I'm multiplying by a form of 1, 5, x plus 3. What I'm doing is multiplying by 1 to have like denominators. Here I've got 3 over x minus 1. I'm going to multiply those by x plus 3 over x plus 3. Okay, and still I'm wondering about that. My determination. So I've got 5x minus 5 plus 3x plus 3, excuse me, 9, over x minus 1, x plus 3. I've got an 8x plus 4 over x minus 1 times x plus 3. And I'm wondering when that's going to be less than 0. Now, does this look kind of a little familiar? I got 2x plus 1 up there. I got 8x plus 4 on the bottom. But it's almost the same function. So I'm really using the sign chart. This sign chart up here is going to drive this the same way. Okay? They're the same, very similar functions, except for the fact that I've got this is multiplied by an 8. So with that said, they're asking me solve that. When's it going to be negative? And it's going to be negative between, get my answer in here, negative infinity to negative 3, negative 1/2 to 1. And that's my final answer there. But I wanted to make sure you saw what would I have to do in case it was given to me this way. I have to get it to this point, and then I can do the sign chart mock-up. But I did it in such a way that it was similar to the previous one, so we could work on that as well. That's what I have today. Tomorrow, we have the last 4 examples. Okay, and all new material will be covered sign chart-wise. We go over restrictions with square roots and absolute values with sign charts tomorrow. Okay. And then your assignment is up on the board, but I'll get those last 2 things there, and it's there as well. Hope things are going well. Hope you guys are having a great night.